Hi, I'm Mr. Franklin, and in this video, we're going to talk about solving 7-step problems in a digital format. So this first problem is just an example that I'm going to show you the parts of our 7-step problem process, and then we will work a couple of examples together. So our overall process takes 7 steps. And we call it R2-D2 guess, because if you're a fan of Star Wars like I am, R2-D2 rarely gets it wrong, and so that's how we want to be with our math problems. So the first thing we're going to do is we're going to read our problem twice. So R2. The first time we're going to read it through for understanding, and then the second time we're actually going to start looking for specifics. D2 is we're going to draw the problem. Now this is the one part of the problem where you can use shapes and different things to draw out your picture on here. It is generally fairly difficult to do. So if you have some other digital tool you want to, regardless, no matter what happens, you need to create a picture. And I've created pictures in Google Slides and then made it an image and then put it in. I've done all kinds of fancy things. Or you could just draw it on a piece of paper, take a picture, and drop it into the problem. Then you're going to list your givens, all the things, variables or quantities that you know what the value is. And then you're going to put your unknown, which is unknown. It's usually, not always, but usually the question word. So what are we looking for? Then you're going to select an equation from our equation sheet. And let me show you that real quick. It is right here. So you probably are going to want this open in a separate tab as you work. And then from that equation sheet, you're going to select the correct equation, substitute in some numbers, and you're going to solve doing your math. Now, honestly, this is the one part of this process that I don't like doing digitally because you have to be very, very careful and generally have to be pretty good with your math to do it. However, most of our problems aren't going to be too complicated, so it shouldn't be that much of a problem for us, at least here at the beginning. Let's jump down and let's work an example, and I think this will make sense a little bit better. So here's my first example problem. So first thing we're going to do is we're going to read twice, okay, and eventually I probably won't put the hints, I'll just put R2, and you're going to read it twice. If a car traveled at an average speed of 80 meters per second for 220 seconds, how far did it go? So it looks like we're talking about cars. We're looking at, I heard the word speed when I was reading, and we're looking for probably a distance maybe. That's what I got when I read that. So now I'm going to go back and I'm going to circle or mark somehow, and I'm just going to use the highlighter, and I'm going to highlight in yellow key numbers and units just to mark it for myself. Then I'm going to look for the question word. So the question word is how far. That's what we're looking for. And if we were doing this on paper, we might actually label what these are, but I'm not going to make you do that on the digital version. Because you're going to do it right here, you're going to draw the picture and label it. And to insert a picture, all you have to do is go to Insert, go to Image, and then you can insert image, and then you can upload from your computer, from Google Drive, or from your camera, but sketch out real quickly the picture. And I've already done that. So let's select my picture here. There's the picture, open. And then that's going to drop into here. Now that's pretty large. Oh, and it's also crooked. So what I'm going to do is down here, there's the image options here. You can also right click and image options here. Either place, you click on image options. Here, let's do it this way so we can all find it. I just right clicked, image options, and then I'm going to rotate it 90 degrees until it's right side up. And then I'm going to click on it and I'm going to scale it down just a little bit. You know what? And there's way too much picture. So I'm actually going to, I double clicked on the picture and it gave the black bars. If I drag the black bars, not the blue dots, but the black bars, it will also crop your image so that you have a have a reasonable sized image that also doesn't have a lot of extra space being taken up. Okay, so that's how you can put in your picture. Well, now what I want you to notice as far as drawing twice is I drew the picture and I drew my car with a box and circles for wheels. So we're drawing stick figures. We're drawing very basic drawings. We are not being artists. We are here to solve a math problem and to solve a puzzle. So this drawing should be able to tell the story as if I didn't have the question in front of me, okay? So if I were to cover up the question and just look at the picture, I should get a pretty good idea of what's going on. So I have a car, it's gonna travel a distance, which I'm looking for. It takes it 220 seconds to travel, and it has a velocity of 80 meters per second. And there's actually one thing missing here, so I'm going to draw it in for us here just briefly. And what we should put on here is also a vector arrow showing the car is moving to the right, and that's our velocity. So I'm going to clear that out for now, but you should add that to your notes, to your picture. So now we're going to list the givens. So I was given velocity equals 80 meters per second, and I was given time equals 220 seconds. Notice I typed each one on a separate line, okay? Then for my unknown, what am I looking for? V equals question mark. So now we're going to look at our equation sheet. So let me pull up the equation sheet. So this is our equation sheet. This is what the entire equation sheet for this class looks like. What you're going to notice is for this class at the moment, we are only dealing with this little section right here. And that's what you're going to have in your Canvas when you're working problems. It's just this set of problems. And then in a couple weeks, we will add this, and then we will add this column, and then eventually we will get into some of these others, okay? So right now, we're gonna keep things simple. So this first equation is delta D over delta T. This is the Greek, this triangle is the Greek letter delta, and it means change, but basically that just means slope. So we're gonna use the slope formula for this. So it's D2 minus D1 divided by T2 minus T1. Now I want you to notice something real carefully here. See the numbers that are down below, which are subscripts. They just tell us which distance we're talking about. They're not an actual number in the equation. So like right here, we have 1/2. That means we will actually multiply times 1/2, okay? But right here, it just means it's the second distance, and this one is the first distance. So we do that a lot in physics. We'll put a little subscript next to something. So you can even see it over here with force. See over here, there's force, and then there's a little average down below. That means it's the average force. We're just trying to describe which force we're talking about. So same over here. Which time are we talking about? So we have that one. Then we have velocity equals distance divided by time, distance equals velocity times time, and time equals distance divided by velocity. Now I want you to notice that these are actually the same equation. We've just done algebra with each one of those to manipulate it for a different variable. In the future, you're going to get to where you're going to do the algebra yourself, but to keep things simple so that we can focus on the process of solving our problems, we are going to have done the algebra for you, and we're going to select the correct equation. Okay, so let's go back to our problem, and let's see. We've got distance is what we're looking for. So we're looking for an equation here that says D equals. So let's go back to our equation sheet. We have exactly what we're looking for: distance, velocity, and time. So if we go back to our problem, we've got distance, velocity, times time. Okay, so now I'm going to substitute values. So do I know D? No, I do not know the value of D, so I just type the variable. Equals, do I know V? Yes, so I'm going to put it in parentheses. I like to do that because eventually some of our values that plug into the variables can be complicated. And if you always put it in parentheses, you will be less likely to mess up the math as we go forward. Okay, and I do the same thing with time. So I've got velocity times time. I substituted, and now I'm going to solve. Now this one's actually pretty simple. Distance equals velocity times time. So I'm just going to use my calculator on my computer. You could use the one on your phone. So I'm going to type 80 times 220, and it's 17,600. 17,600. But now I've got units here. So I've got meters per second, but I've also got seconds. And if we write that out by hand, what we would see is seconds is on the bottom of a fraction here, and this one is actually on top of the fraction, and the seconds would cancel. And we're going to get D equals 17,600 meters. Okay, so let's pretend like I'm going to grade this. So you've read it. I can tell because you've marked the variables in units, quantities in units. You've drawn a picture, so that's +1 point. You've done your givens and your unknown. Both of those together is +1 point. Then you've written the correct equation, so that's a 1 point. You've substituted the correct values into the equation. You've solved appropriately. So in other words, you found the correct answer and you've written the correct units. So you found the correct answer and you've written the correct units. So +1 + 1 is 2, 3, 4, 5, 6. So +1, 2, 3, 4, 5, 6, 7 for your solution. This is pretty important because this is about the process. There are many of you that could have done this problem. You could have read that problem. You would have multiplied those two and come up with the answer straight away, but you would have only gotten 2 out of 7 points, which is about 28 or 29%. And if you did that on a test or on a homework and you got a 30%, then that's not so good, okay? So make sure that you're doing all the steps. On the flip side, let's say we get to some problems that are more difficult, okay, more difficult, and I can do the drawing and I can list my givens and my unknown, but I'm stuck here. I don't know what to do here, okay? Well, you've got 2 points, plus I know that I'm looking for distance, so I know that the answer has to be in meters, so you can write the meters here. Well, there's another point, okay? So there, you can get partial credit for working as many steps as you can. Maybe you get the equation correct, but you don't solve correctly. Okay, there's all kinds of ways to do this and still get plenty of points worth of credit. The other reason I want you to really make sure you're doing the process is eventually we're going to be doing much more difficult problems, and I don't want you to be struggling with the process when I really want to talk about the physics of what's going on. Okay, so a lot of this is placeholders so that, one, I can take a quick glance and go, oh, you messed up here or you messed up here. And then I can help you gain some understanding and solve and figure out what's going on. The other reason is eventually these problems will get more difficult, and maybe this is the only thing that makes sense. And that might be what you need to figure this out and solve the problem. So it's not going to be clear exactly which thing is going to unlock the solution, especially as things get difficult. But if you do the process, they really won't be difficult. So do the process. Okay, so that concludes this section of the video notes. If you feel comfortable, you can go straight into the homework problems and work through those as best you can. If you want to see another example, I'm going to work another example and show you how to do that. So I'm going to go ahead and show you the next example here. So here's our new problem. So here's our new problem. So we're going to do R2D2 guess. I'm going to read it once just to gain an understanding of what's going on, and then we'll read it and mark it. Here we go. A snail runs 0.008 meters, which is the same as 8 millimeters, over 4 seconds. How fast was the snail going? Okay, so we're talking about snail. Looks like we're looking for speed. So let me mark it and make sure. So 0.008 meters. Nope, I didn't mark it. 8 meters, highlight. There we go. 4 seconds. 4 seconds. How fast is the question word? Okay, so now I'm gonna draw. So I drew it on paper. I told the story. So that's what I would do first is I would start with the story. Let me go to insert image. This one is in my drive. So I'm gonna click on drive instead of my desktop. And we're looking for the snail problem. There's my snail problem. I've actually worked the whole thing on paper, but I'm going to just show you my drawing. I'm gonna resize it for what I need. Okay. So I've inserted the drawing. So I'm going to explain what I did with my drawing since I'm not going to show you as I draw like I did in my other video, but we are interested in telling the story, but also doing it quick. So I don't know how to draw a snail. I'm not going to spend 30 minutes trying to draw the perfect snail. So I drew a circle and I filled it in. That's my snail. It could be a soccer ball. That could be a human being. I don't care what it is. That's good enough for our physics. It's going to run a distance. So I drew little bars to represent the distance it's going to run. So it's going to start here and run to here. And then that's going to be 0.008 meters. Notice that that's much longer than 8 millimeters, okay? So we're just representing what's going on. It doesn't have to be accurate. We're not measuring anything on the page. This also happens to be the length of time it takes for 4 seconds to happen. So 0 seconds is here and 4 seconds is over here. 0 meters is here and 0.008 meters is over here, okay? I've also marked what we're looking for. We're looking for how fast, which is a velocity, equals question mark. And I also drew the arrow, okay? So now that picture is complete. It tells me the story and everything is labeled properly. I have the variable, I have the number, and I have the unit, or I have the variable and I have a question mark, okay? Now we're going to go and list our givens. So our givens is distance equals 0.008 meters, time equals 4 seconds. Our unknown is velocity equals question mark. My equation. So let's go to our equation sheet real quick. Equation sheet. And I have velocity equals something with time and distance. So velocity equals. Well, it's right there. Velocity equals distance divided by time. Because remember, we wrote d2 minus d1. Do we have two distances? Trick question, do we? Not in the word problem, but if you look at the picture, we actually do. So we could do d2 minus d1. But guess what? It's going to still be 0.008 meters, right? Okay, so there's no point in doing that equation, but I wanted to show you that. We're going to do this one right here, okay? We're going to do that one right there. So V equals distance divided by time, okay? And so because of images, it looks like it took up a lot of space on our paper. So I'm going to substitute. So I'm looking for V. I don't know what it is. Distance, what is distance? 0.008 meters. 0.008 meters, parentheses, divided by 4 seconds. So parentheses, 4 seconds. Now I'm going to solve velocity equals 0. Here, let's just calculate it. Pull up the calculator. So 0.008 divided by 4 is 0.002. 0.002. I always put the 0 in front of my decimals so that I know that there's a decimal there. Okay. Units. We've got meters divided by seconds, so this is going to be meters per second. Meters per second. There's nothing else really to work. I've got it right there, so my answer is complete. Velocity is 0.002 meters per second. I've got an answer. Okay. So we've read twice, we've drawn and labeled, we've written our givens, we've got our unknown, we've written our equation, we've substituted, we've solved and shown all of our work, shown all of our math, and now we have an answer with units. There you go. So now what you can do is go to the practice problems and work through those as best you can. Make sure that you do as many of the steps as you can. Alrighty, that concludes this video on doing these digitally, and I will see you in the next video.